What's really exciting about the future is the potential for more personalized medicine. I had a patient once who said to me, "You don't know what to prescribe to me. You're like throwing darts at a dartboard." And he was right.
Joel, thank you so much for taking the time to have this conversation. I've so been looking forward to this.
Thanks, Brandon. I'm really excited to talk with you. And I must admit, I'm really excited about the stuff you're doing. Educating people, getting them to understand what clinical trials are all about is going to be good for them. It's also good for us as researchers. So thank you.
Yeah. And Joel, you've had a fascinating career. Maybe for the folks at home, give us maybe just like an overview of what you've been doing and how you ended up as the Chief Medical Officer over at Arrivo.
Well, sure. I'm a psychiatrist by training. I trained here in Toronto. I actually never thought I would become a psychiatrist, but I think it's in my genes. And my father was a psychiatrist. And during my training, I really wanted to avoid psychiatry because of that, you know. And but I was so fascinated by the whole diagnostic process, trying to understand what was going on with people and the mechanisms underlying that. And when I did psychiatry, suddenly I was like captivated by the fact that the brain could do so much. Like, I mean, It could make people catatonic. It could make people psychotic. It could make them mute. And I was fascinated by it, like, how? And we didn't really know that so much back then. And that really got me interested in the whole diagnostic process, trying to understand how the brain worked. And that led me into psychiatry. I really did focus a lot on the psychopharmacology side of things, but also really wanted to take a holistic view because I felt there had to be other things that were influencing how the brain was showing these symptoms, you know? And so I got involved when I graduated in academia. I started at Mount Sinai Hospital in psychiatry and oncology. Yeah. But I felt like I just wasn't connecting enough with the patients I was seeing. And so I went out to the community. And I was the only psychiatrist for 100,000 people. So it was incredibly busy. Right. I saw children, families, adolescents, adults, older people, nursing homes, the jail. And I loved it. But it made me realize that our treatments weren't good enough. I wasn't good enough. So many people were, you know, maybe somewhat better, but not fully better. And I started trying different medications, different combinations of things that really hadn't been researched at the time very much because I couldn't get referrals to send them to people. The waiting lists were so long. And that really got me interested in the research. And the pharmaceutical companies started, you know, approaching me and to get involved and do some teaching and which I loved. And that really got me involved in more of the research when the Center for Addiction and Mental Health in Toronto recruited me back to head up the depression program and set up a clinical trials program for mood disorders. And that was great. It was fascinating work. And we were really doing a lot of very new research and very exciting research. But I still felt that it wasn't enough. And I think I'm my own worst enemy sometimes, Brandon. But and I was approached by several pharmaceutical companies to join them. And I joined Eli Lilly at the time. They were really the psychiatry company, and they had several leaders who were from the NIMH in the States. And it was really an amazing opportunity for me to try different things, learn not just the research, but advocacy work, working with patient groups, working with governments to try to improve access to mental health services. It was really a fantastic 20 years. And then I retired and thought, all right, maybe I'll consult a little bit, you know, but enjoy life a little bit more. And I was approached by a company that I currently work for, Arrivo, who had this very fascinating compound, early stage, that had an epigenetic mechanism of action, and there's really nothing like it. And that pulled me out of retirement to become their chief medical officer. And it's incredibly exciting. And I think it's an incredibly exciting time for psychiatry as well, or neuroscience, because there's just been an explosion in the last few years of research and understanding. And I think it's going to keep me going for a little bit longer.
Yeah. Before we get into the Arrivo story, a lot of guests that we've had on the show have spoken about maybe this neuroscience and psychiatry renaissance that we're in right now. Yeah. What do you think is happening in this point of time that is coalescing?
Well, I think that we're starting to understand the mechanisms a lot more. Our knowledge of the brain, of the receptors, the neurotransmitters, I think we're starting to learn that we used to always think of circuits in isolation, and now we're recognizing the connectivity issues and some of the excitement around neuroplasticity and brain resilience, opportunities to change brain patterns of communication, brain patterns that manifest in different behaviors. It's really opening up. I mean, the brain was decades behind what we knew about hypertension or the heart or the lungs, but now it's finally starting, and with more tools being able to evaluate things, whether it's different scans, whether it's QEEG, different measures we're starting to incorporate. We're learning so much more. I think it's leaning us, and I know you've had previous podcasts talking about precision psychiatry.
Yeah.
The goal, I think, is really we're starting to learn is, how to tailor our treatments to the individual. And that's incredibly exciting.
Yeah. And, in digging into the Arrivo story, I think there's two really interesting things that I'd want to kind of cover here. The first is this idea of an epigenetic MOA or mechanism of action. That's rather unique. I'd love to learn more about that and what that even means. And the second one is it seems to be that there's a gendered kind of a difference in effect, and would love to dig into that as well.
Sure.
But maybe let's start with mechanism of action. Like, what is this idea of an epigenetic tie to mental health and mood disorders?
Sure. Epigenetics is how the environment and our behaviors affect the expression of certain genes. And that is something I think we've known about, but have never really been able to do anything with. So right. It's something, and I think one of the ways to think about epigenetics is that we can look at it in the context of depression, for example. We know that people with depression, especially if they have more and more episodes, develop certain fixed ways of thinking. And those ways of thinking are potentially maladaptive. And those, so that when there's an environmental stress, rather than being able to think in a more positive way, these maladaptive pathways that have become fixed occur, and that manifests itself in the depression. We can go back and think about that there are links between depression in women and early childhood trauma. And the idea is that that early childhood trauma creates this chronic stress reaction. And then over time, it doesn't take very much in the environment or the behaviors then to tip that chronic stress picture into a depression. And there are other diseases. It's not just depression when we talk about epigenetics. I mean, one of the things that is so interesting to me is that depression is 2/3 female. Now, that's not just related to hormonal factors, because independent of that at different ages, it's still 2/3 female. So why? Well, there are other diseases that are also more prominent in women. For example, if we look at some of the immunological diseases, the inflammatory diseases, lupus, rheumatoid arthritis, MS, those are more than 2/3 females too. So and we know that exacerbations of those diseases can occur with stress. And so there's this stress immune inflammatory epigenetic mechanisms that's occurring across diseases. And we're only now starting to learn how, the expression of these genes can impact the course of the diseases.
Yeah, so maybe this is a nice jumping off point for this lead asset that you have over at Arrivo. Maybe tell me a little bit more about the story there.
Sure. The lead asset we have is known as SP624.
It rolls off the tongue.
That's right. But we just recently got our USAN name, which is Forviservat. Forviservat. And so I'm going to call it Forviservat just because I'm trying myself to change.
I did just see the
And it's a SIRT6 activator, sirtuin-6. Now, sirtuin-6, or SIRT6 for short, is a fascinating enzyme because it has multiple roles. And it's mostly in the lay press known for longevity, for neurodegenerative diseases, and also for metabolic homeostasis. And that's where a lot of the things are. And there are now SIRT6 diets that you can, that are, advertised. I don't think they're really effective, but they are there. But SIRT6 has some really interesting roles. So, for example, the first thing it is essential for is for DNA stability and repair. So if you have a break in your DNA, SIRT6 is immediately activated and ends up putting the DNA back together. And so if you think that as we get older, a lot of illnesses, our DNA starts to break, this is something that can help repair that DNA. So it's important for DNA stability and for DNA repair. The next thing it also does is it silences certain genes, SIRT6, and some of those genes are involved in the inflammatory processes. And by silencing it, stops the genetic material from unfolding. And the idea then is that if it doesn't unfold, it can't produce the proteins and such. So it silences certain genes, and it has this anti-inflammatory effect. The third thing that it does is it's very important for mitochondrial health. And SIRT6 and SIRT3, another sirtuin, work together to maintain mitochondrial health. Mitochondria are the batteries of the cell, the engines. And they're essential for cell survival. And mitochondria become more recently a really interesting target in a lot of different diseases. We were starting to look at the mitochondria as a target. And so mitochondrial health is really essential for cell survival. And then the final thing that SIRT6 does is maintains metabolic homeostasis. And there's a lot of literature on it that it can bring down glucose, for example. And in our clinical trials, we found that actually for people who were hyperglycemic, it actually brought their glucose down to normal levels. And we've seen this in our animal studies as well. It also decreases lipids and cholesterol. But if your glucose is normal, it doesn't make you hypoglycemic. So it's a homeostatic mechanism. So SIRT6 is this enzyme that's really, really crucial for our entire homeostasis of the body. So we have this compound, Forviservat, that is a SIRT6 activator. And it increases the activity of SIRT6, depending on the different assays, 40, 50 times. And so we started studying it in actually depression. We're a small company. And I could see studying it in neurodegenerative diseases based on the DNA repair and the anti-inflammatory and the mitochondria, but as a small company, that was beyond our bandwidth to be able to do an Alzheimer's trial. But there was a lot of really good animal data supporting its antidepressant effect. Now, we always have to be careful. Mouse data doesn't always translate into human data. But in all the different mouse models studied, Forvisirat had this antidepressant effect. And it also has a pro-cognitive effect. And we know that lots of people with depression suffer from cognitive deficits, difficulties thinking, concentrating, attention, memory. So it seemed like a very good target to study in depression. And we did a very large phase 2 trial, over 300 people, which is big for a phase 2 trial. But because this was the first time a SIRT6 activator had been used, we wanted to collect data to learn about it as well. And the study missed on its primary in males and females with depression on the MADRS, the very classic scale, although it trended in the right direction. And so the first cut we did was looking by sex, and females did really well.
Wow.
And males showed no effect.
Wow.
We were scratching our heads, Brandon.
Yeah.
I mean, is this a real effect?
Right. What explains this?
Is it a fake effect? Yeah. We weren't sure. When we designed the trial, we actually included a 1 week off drug part where everyone knew they were off drug, but they didn't know whether they were on drug or placebo. And we wanted to see whether efficacy was maintained in that 1 week. We wanted to do that because in the animal studies, we saw that after a single dose, the animals maintained their effect for over a week. And this drug has a short half-life, so it's not like a receptor drug where, like an SSRI or an SNRI, our current drugs where when they're on the receptor, they work, and when you stop taking them, things revert back. There seemed to be this maintenance of effect, this long-term potentiation. And so we did that, and we found that the females continued their improvement or maintained their improvement, and the males started reverting back to baseline, which suggests it really was a true drug effect. And so then the question becomes, why? And that's when we went back into the literature, and I think we all sort of thought, we should have read this article by a Dr. Sine from Pitt, who wrote published in 2018, that there are a number of genes that are expressed differently in males and females with depression. She looked at people who had died, who'd had depression, and found that there were 1,027 genes that went in different directions in males and females with depression.
Wow.
And 52 of them were statistically significant. And her conclusion was a drug with an epigenetic mechanism of action could have opposite effects in males and females with depression. Boy, we wish we'd read that paper. Wow. I know I've said that already, but and since then, she's done, and others have done some animal models showing that there are these differences. Males and females have different gene expression when in the animals when you use them in depressed models. Chronic, unpredictable, mild stress model is a classic one. And males and females, when you do that, the mice, they behave differently. And when we give them our drug, so it's fascinating, actually. It's preliminary, so I guess I can probably say it. But there's been other animal data supporting this as well, that males and females in this model behave differently. But what's really fascinating when we started looking at the animal models is that most of the companies that do animal models don't do female animals. So when we said to them, can you do a female mouse model? They would say, we don't do female mice. And so we've known for a long time that males and females are different.
Yeah.
And in depression, I mean, going back to 2000, there are articles written that males and females respond differently to drugs, to our antidepressants. Susan Kornstein in 2000 wrote that women respond better to SSRIs. Men respond better to tricyclics. And that was followed up the following year by Dassenbach, a colleague of mine at Lilly, who did a study and showed, again, very similar results. And we now know that females have more alterations in some of the serotonergic genes, differential expression and variability in those genes. Males have more variability in the norepinephrine and dopamine genes. So that kind of explains what we see clinically.
Right.
You know, and so we now have this body of evidence to suggest that there is a epigenetic difference between males and females, and so we're now doing another study to confirm those findings, studying males and females still, but our goal is to prove that this drug has a preferential effect in females. And I think that's incredibly exciting because it leads us to more personalized medicine and the idea that we're not in a one-size-fits-all situation anymore.
Yeah. So let me make sure I'm piecing this together. SIRT6, it's an enzyme that has a few really important effects. One is rectifying DNA breakages. One is in the mitochondria, and the last one is on glucose levels. And this somehow
overall metabolic
effects. And this somehow influences the differences in gene expression between men and women. Help me understand the linkage here.
Sure. So I can't really tell you what of all those different things is the one that's really the key antidepressant effect.
Right.
You know, we do know that people with metabolic disorders have higher rates of depression. That we know.
Right.
We know that people with mitochondrial dysfunction have higher rates of depression and other neuropsychiatric disorders. And we also know that epigenetics plays a big part in depression. And we know that there are differential effects between males and females, both in animal models and in humans. Not just in response to treatment, but even the way depression appears is different between males and females. Females have more of what we call more of the internalizing symptoms, guilt, anxiety, whereas men have more anger and irritability. The symptoms are different. And so we have to assume that the underlying pathways, and this gets back to what I initially got excited about psychiatry, the underlying pathways have to be somewhat different. There's obviously some overlap. So SIRT6 activation with forvisirat probably has multiple effects. And we know that when we look at it in cell models, for example, we know that there are effects on increasing glutamate, which is a target for a number of different antidepressants at the moment. We see increases in AMPA receptors, not NMDA, which is a target and which has had mixed results recently. Right. And with that, we then see increases in a number of different pathways, including BDNF, brain-derived neurotrophic factor, which is important for neurite sprouting and new growth. We see signs of long-term potentiation and neuroplasticity. Yeah. And through that, we then also see increases in the neurotransmitters, like serotonin, for example. But all these other pieces that are occurring. So to me, it's maybe when we think about receptor-based drugs that we currently have, we're hitting a target downstream. We're hitting kind of everything. By having an epigenetic mechanism, we're upstream. We're much closer to the source. And that for me is incredibly exciting because we have the opportunity then because it has neuroplastic effects and we're at the source, we can actually change the course of the disease, not just the acute episode,
Right.
which I'm hoping we will be able to treat. Time will tell, But if you have a neuroplastic effect with therapy, in conjunction with them, and we're seeing this some with the psychedelics now, that we may be able to change the long-term course because people can start having their thoughts, their automatic thoughts now that have been negative for so long and maladaptive. We can create new pathways. And we see signs when we give Forviservat that we see increases in some of the proteins associated with synaptic transmission, with the ribosomes and the vesicles that enclose the neurotransmitters. So we know we're doing what we need to be doing, but we're upstream. And that makes it more specific. And for me, that's incredibly exciting.
Yeah, fascinating. So I'd love to maybe dive into this next study that you're thinking about. You did the initial kind of analysis. It seems like there's a pronounced effect in women versus men. And now you're doing another study to kind of confirm that. How do you think about study design, logistics? For a study like this, to my knowledge, this is probably one of the first studies that has specifically looked at gender-based split in effect.
Study design is there's the simple part, and then there's the art. There's the science and the art. You have to do certain things to have a regulatory approval. So you're mandated to do certain things, and that's easy. The challenge is you want to try to answer certain questions as well.
Right.
And with every study, you also want to learn. I like to think that a study will answer questions, but it's also going to develop questions that we need to answer because we can't know everything right away. And so what we're doing in this trial, and it's currently ongoing, we're getting close to halfway enrolled. But it's a big study, and essentially a lot of it is replicating the first study, very similar, because we have to prove that was a real effect. But a couple of things that we've done differently is we're actually we've included a cognitive scale because we believe there is probably an independent pro-cognitive effect. And we just got some other data which really supports that. But I won't get into that right this second.
That's a future episode.
No, I have to talk about it because it's really, really something. The challenge becomes with study design is getting the right people in, right? And I know you're doing a lot of work on these podcasts trying to educate people about what they're getting into, right? Yeah. When you're designing a study, you want a homogeneous population, right? You want as little variability as possible. Because that way you can really assess your drug effect without extraneous factors. But that's not the real world, right? So when we design a study, we exclude people with anxiety disorders and PTSD and ADHD, substance abuse. In the real world, when you see people, they've got comorbidities. Yeah. They're on other medications. So it's trying to find some kind of balance. I really believe in keeping things simple, not overloading studies with tons and tons of scales. And part of that reason is I think the more you do that, the more you increase the placebo response. And placebo response is a factor not just in depression, it's in all trials, but it's been going up, and we're seeing 30, 35, 50% placebo response rates, which means you have to have a huge study. Right. If you want to. And so I like to keep things simple. One of the things I tell investigators, and it was something that I used to do as an investigator, is I would tell people, when you enter a study, you're not a patient. You're a subject. I'm not going to be nice to you. I'm not going to talk to you about a lot of things. I'm going to administer my scales. I'm going to ask you about side effects. And that's it. You'll be a patient when you finish the trial. If you want to be a patient, don't come into the study. And that's hard for investigators and for physicians because we want to help people.
Right.
But it's really key, I think, to put limits on that engagement during a trial and be as objective as we can.
Because familiarity and personal relationship and these things influence.
Absolutely. So in this trial, we're also doing a 2-week off-drug phase now to look at that and see whether that long-term potentiation effect is maintained. And so we're very excited about it. It's a fairly simple trial, but it's a big trial. And we'll see.
Yeah. What if, like, as a man, considering this study, why would I even want to participate, knowing what we know already about the kind of history here?
Sure. Right now, our belief that it's a drug that would work preferentially in females is a hypothesis. It's not proven. And we do know that this drug will increase serotonin, probably dopamine, in men and women. And so there could be an antidepressant effect for men as well. As I said, this second trial is really to prove a hypothesis. And so it's not proven yet. There's a lot of evidence, like I said, in animals and in our first study, but animals aren't people. And there have been lots and lots of drugs that have looked great in mice. And have bombed out in human studies. So I think, I don't know. If it works in both, that would be fascinating. Maybe it would work in men and women. Maybe it will work a little more in women. But again, I don't know. So I think it could have an effect in men. These are questions that we just don't know and we need to answer. The first study with a drug that had never been put into people before with this kind of mechanism, like I said, a good study raises questions, Brandon. We have a lot of questions that we need to answer. I think it's potentially a good study for men and women. One of the things, another reason, though, that we made it a short study. It's 4 weeks of treatment. Because...
And then, 4 weeks of treatment and then 2 weeks.
And then 2 weeks, yes.
And then return to be reassessed.
Right. But, after 4 weeks, you don't have to do that 2-week phase, I mean, people can, and you don't have to do the 4 weeks. People can drop out of a study at any time. But because it's hypotheses, we didn't want to do a long study. And we did see effects early on. After 2 weeks, we started seeing signs of efficacy. So I would say that it's an unanswered question. We're excited about its potential in females in particular, but that still has to be proven.
Yeah. And I'd love to maybe spend some time just thinking about the pro-cognitive effects. Is this also differentiated by gender?
Well, great question. And so far, we don't think that the pro-cognitive effects are gender-specific.
Fascinating.
And the gender-specific seems to be potentially a depression effect. And so in animals, in different models, and you can use scopolamine, which is an anticholinergic, and there's the PCP model that produces cognitive deficits. We saw improvements. But like I said earlier, only male mice were studied back then. But it worked in the male mice. We just recently completed the first cohort of a healthy volunteer study where we looked at quantitative EEG in people given for Viscervat. And the idea was we would look at, after a single dose, was there an effect on the EEG? And then after 2 weeks of dosing, was there an effect on the EEG? And we used the dose that we used in our first antidepressant trial, 20 milligrams. So, because this would help us, again, answer, is it a true effect that we saw in depression? Is there a biological effect? Are we seeing a signal in the brain at 20 milligrams? Because depression trials, by the way, are tough. There's no, not like diabetes where you can do an A1C.
It's all subjective.
Yes. So we did this QEEG study, and we found that after a single dose, 3 hours afterwards, after the dose, we saw increases in alpha, beta 1, beta 2 waves, which are the high frequency waves, which are associated with improved connectivity, rapid processing, and suggest improved and enhanced communication between neurons. And so that is incredibly interesting, because these were healthy volunteers. We didn't know if we would see an effect in healthy volunteers. And after a single dose, we also saw a decrease in the slow waves. And that's really important because people with depression have increases in the slow waves. And so we were seeing pro-cognitive and antidepressant effects in healthy volunteers after a single dose. Wow. We also looked at evoked response potential. So give people an auditory or visual stimuli and then look at the EEG in response. And again, we saw signs of increased processing and neural effectiveness. And those were maintained or improved after 2 weeks when we did the repeat dosing at day 15. We did divide them into males and females to answer your, and we didn't.
Seems like you got it at this point.
We didn't see a difference, but the ends are small.
Yeah.
So now we're doing another cohort with people with depression, same study, with QEEG, but we're also adding a computerized cognitive battery into this group as well. And we're going to see whether or not the cognitive changes we see are the same in people with depression, and is there a sex difference?
Right.
So
now
you'll have to invite me back to get the answer.
I'm too curious not to. Now this kind of let's call it adjacent effect around cognition is fascinating, because cognitive impairment is associated with a lot of other psychiatric and neurological conditions. How do you think about the roadmap for other places you might want to take this research in this compound?
Well, you're right on when you think about the cognitive effects across so many different illnesses and diagnoses. And I could see it being potential of use if we first start in the psychiatry realm, right? I mean, schizophrenia, for example.
Yeah, CIS.
Especially the negative symptom folks. I could see there being benefit there. Given the way CERT6 works, to me, there's an obvious translation into neurodegenerative diseases like Alzheimer's disease. The fact that it stabilizes DNA. And people with Alzheimer's, by the way, have much lower levels of CERT6. So CERT6 drops with age in normals. And we get our DNA and telomere breakages, and we can't repair them as well. That's aging.
Yeah.
But with Alzheimer's disease, they have even lower levels. So that's a sort of logical step. And then other neurodegenerative diseases that have cognitive impairment, and we could think about Parkinson's disease, for example.
Yeah.
So I think there's a lot of opportunities. The other piece that I think is very exciting about this drug is that we know that lots of people who suffer with mental illness have metabolic issues, and some of those are side effects from the drugs. Potentially a drug that at least helps homeostasis. could be helpful for some of those folks as well.
Sounds like you have a lot of future research you want to do. What do you need to hit in the near term to allow you to do that?
Well, I have to stay healthy first,
Of course,
because I really am so excited about it. First thing we have to do is complete the studies we're doing.
Yeah.
So we need to do this depression trial and finish it, and hopefully it gives us positive results. That's step number one. And whatever the results are, we're going to learn a lot. And so a negative trial doesn't necessarily mean it's finished, because you have to analyze the data and look and see, and lots of compounds maybe fail on their primary in phase 2 and still go on to be successful. We'll see. I'm really excited to look at the data, and this study is being done really under. We're making it a regulatory ready sort of submission ready study. I mean, we really have a stats package that I think is we really want to look and understand and learn. And the regulatory agencies want to learn as well.
Yeah.
So they've been very collaborative, and it's been very good. So we need a positive study. Our cognition study, that cohort 2 in the depression folks, I think will also provide us with, a lot of valuable information. And then the third piece is we're continuing to do a lot of animal work to try to understand the mechanism of action more. Not just the sex differences, but the effects of SIRT6 activation and how it can affect and how we can measure it through the neuroplasticity and effects on other proteins that maybe are expressed through the genes. So we're really trying to understand fully that mechanism of action. So that's what we have to do.
Yeah. Well, Joel, you've been on the front lines in practice. You've been behind a lot of different success stories in research. How do you think that the kind of future of practice is about to change, given everything you're seeing today? That's so exciting.
What's really exciting about the future, I think, is the potential for more personalized medicine. I said earlier that right now we're often in a one-size-fits-all, and I had a patient once who said to me, "You don't know what to prescribe to me. You're like throwing darts at a dartboard." And I remember that, and it's been 30 plus years since that person said that to me.
Yeah.
And he was right.
Right.
In a lot of ways, he was right.
Yeah.
And so the excitement of learning what's happening now as we learn the mechanisms, I think we're going to be able to start tailoring treatments. And there was always a mantra in research where you wanted to develop the right drug for the right patient at the right dose at the right time. That still holds true. But one of the things that we don't do well is who's the wrong patient for the drug.
Right.
And I think our understanding the mechanisms of action are maybe developing more of some biomarkers, for example, may also lead us to more personalized treatments. And that for me is incredibly exciting.
Yeah, absolutely. In conversations with, some of the folks looking at neurocircuitry, including the TMS group out of Stanford, and some other kind of like ways of thinking about precision medicine, it certainly seems like we're starting to see the early indicators for how we might tailor treatment plans, where historically, as you've said, it's been throwing darts at a dartboard.
We have a way to go.
Yeah.
And one of the big challenges of neuroscience research is you can't get a biopsy.
Yeah.
And and PET scans are very expensive and prohibitive. And the other challenge, I think, is that when we do studies and we say the drug works, it works in a group. We're looking at groups. One of the big challenges is how do you translate that to the individual in front of you as a clinician, right? That data, because remember, the patients who are in studies, the subjects who are in studies, aren't always the real world people that we see, people with complex issues, other diseases, other comorbidities. And so we need to help clinicians take that group data and translate it to who's the right patient, right in front of you, and who's the wrong patient. And I think we're getting there, but we still have a ways to go. I really hope that, in time, certain biomarkers. When I was a resident, I was involved in a project where we were using the dexamethasone suppression test to see whether or not, if you gave people some steroids, whether or not their suppression of their steroid system would predict a response to a drug. And we also used a low dose stimulant to see if that would predict response to a norepinephrine drug. And we were really excited. The science said, "Oh, it should work." It didn't work.
Right.
So, but we're learning, and I think the potential is incredibly exciting. And it gets me back to a little bit what we were talking about off camera, which is how important what you're doing is, because you're getting people to understand, what clinical trials are, what's going on, and hopefully encouraging them or enabling them to get into the research, because without those folks, we can't do these studies.
Certainly. Well, it's been an exciting time to peek behind the curtain on this research. We've said it many times, there seems to be a renaissance here, largely driven by the exciting work that you and your contemporaries are leading. So I'm just thrilled to be a small part of telling that story.
No, thank you.
Yeah.
I don't think you're a small part, but thank you.
Well, we're doing our best. Well, Joel, you may know my traditional closing question, which is the magic wand question. If you could change anything about the way that that research is done today, or that it is brought into practice, what would you change?
I would change the way we actually measure symptoms.
Yeah, the subjective, objective.
Yes. So, right now, you do a depression study, for example, someone comes into the office every week and they get a MADRS scale, a HAM-D, a CGI, different scales. What if they didn't sleep well the night before? What if they had a stressor that morning? Or what if something, affected it? For that time that they're there, is that really an objective measure of how they're doing? For me, I would want to start incorporating digital assessments, whether they're things that are automatic, like measures on your iPhone, so that we're getting 24-hour things, activity. I mean, we can measure activity through your phone. We can look at when you dial, your phone actually can pick up where in the number you are. Are you on the edge? Are you in the middle? How many times are you? And those can be affected by illness.
Right.
Actigraphy, it measures activity, sleep.
Vocal biomarkers, I've been hearing a lot about.
Yes, absolutely.
Yeah.
And I've been very fortunate to consult with some companies that are involved with that, as well as some AI companies that are looking at ways to enhance clinical trials and decrease placebo.
Yeah.
But for me, I would want real-time assessments that are independent of that interaction that I would have with the subject in my office.
Yeah. It's remarkable how often this theme of the challenges of subjective scales comes up in this department of psychiatry and neurology. Everyone seems to be grappling with it, and the placebo effect certainly is not helped by it.
Well, if you ever attend a rater training for a study, I don't know if you ever have.
I have not, but maybe I should.
I would really encourage you to attend.
I would love
you will
to.
see experienced investigators rating a video of a patient.
Yeah.
And the variability in the ratings are really something.
Well, maybe you'll let me attend the next one.
Okay.
Would love that.
That's a standing invitation. You got it.
Please. Well, Joel, I so appreciate you taking the time to have this conversation. Thank you so much for educating me about the work you're doing.
No, thanks, Brandon. I really appreciate the opportunity. And hopefully we get the chance to talk again sometime.
Not at all. My pleasure. And we'll bookmark this for the next conversation.
Sounds great. Thanks.
Thanks so much.